BQ2404X, that is very important, I see. Okay, so I think in the last two lectures, they discussed this charging module. Okay,
Yes, sir.
that is very important. Along with that, I think if you remember, so they discuss charging profile. So if you charge, so the charging will be done in three different stages. One, okay. So it will be called the pre-charging. That will be the constant current charging. The last one is the constant voltage charge. Okay, these are the three different conditions.
Yes, sir.
Here to here. Okay, this current is I preterm. This current level is I fast. This current is I termination current. Okay, so how we calculate the preterm current I preterm, that will be also explained in the last 2 weeks. I fast charging current and I termination current. These three parameters are very important for the charging module. Okay,
Yes, sir.
so how we calculate these currents if data sheets is given, okay, or the parameters values are given, how we calculate these particularly three value, that will be also discussed in the last 2 weeks. So that is the important part only. Okay. In this one, this in week 9, this is the important thing.
Sir, what is the question from this week? What type of question?
They will give you some values and ask these particularly three currents.
Okay,
This
okay.
type of question is possible. Second, if we are talking about, uh, they give you a block diagram form and then ask some parameters values. Okay, how we calculate the parameters values. Only calculation, not a remembering thing. How we calculate the parameters, that is you have to understand in this week 9.
Okay, sir.
Okay, like for example, I just give
Yes,
one
sir. Yes, sir.
three
Can you give
two
one example?
24040. Okay, one block diagram is given. This particularly current you have to calculate. Okay, for calculating this current, some parameter is given in the data sheet and some parameter will be given in the block diagram. Like one resistance is given, that is R term resistance. The value of R term resistance is let's assume that it is a 10 kilo ohm or 20 kilo ohm. Okay, now they are asking the item. Okay,
Yes, sir.
so this type of questions they are giving. Except this, I think actually everything will be the theoretical from week 9.
Yes, sir. All are theoretical.
In week 10, some calculation part is there, some parameters is there. How we calculate these parameters, how line regulation, load regulation, like that.
Sir, week 10, I didn't go through that part. I am studying this chart that is last 2 weeks. I
Okay.
couldn't understand from the that this charging chart what I will remember or what
No, no,
the
no. Parameters value are given. Only you have to remember the formula that how we calculate this particular formula. No,
okay,
data sheet is not. You have to remember that. No
okay,
one basically remember the data sheets. It is
okay.
very typical because actually data sheet is the
Yes, yes,
9 page or 10 page data sheets.
yes, sir.
Okay, so data sheets is not you have to remember. Okay, if we ask something from the data sheet, we give you the values in
Okay,
the
sir.
exam. Okay, either in the values or either we provide you the data sheet.
Yes, sir. Okay, okay,
Okay,
okay,
only from that data sheet, some parameter is not mentioned in that data sheet. So how we calculate these for particularly values from the data sheets, you have to remember this thing. Okay, like for example, I am giving you the item is not given in that. Okay,
okay, sir.
if you see the data sheet. Okay, this is your data sheet.
Yes, sir.
If you see in this one, electrical characteristics. Okay, if you see that they are mentioning the I out. Okay, they are not given the I preterm current. What is the preterm current? Okay, they are
Yes, sir.
not giving you the yeah, they are not giving you the fast charging current. Okay, so how we calculate the preterm current and fast charging current? Okay, so we have the formula like if you see here in the data sheet. Yes, R I set is equal to K I set upon I out.
Yes, sir.
Okay, so I out is what? Fast charge.
Okay.
Okay, so if Ki set is given, these are the typical values. Okay, what is the we are using the typical values. Okay, and Ki set is given, Ri set is given in the block diagram. So can I calculate the I out?
Yes, yes, we can.
Yeah. So that is I out is the fast charging current.
Okay.
Okay.
Yes, sir. Now I
So
understood the.
yeah.
Yes, sir. Okay.
Similarly, if you say here the pre-term is equal to K term into the percentage. Okay, percentage is given here either 10% or 11%. So R preterm is given. So can I calculate the K preterm? First of all, K preterm is also given here. Okay. So if K preterm is given here, so we can calculate the term current also.
Yes, sir.
Okay. So I think that will be explained in the videos. Last 2 weeks they calculate that how we calculate this particularly fast charging current or pre-charge current. Okay. Here
Okay,
if you
okay.
see the formula R preterm is equal to K preterm into percentage of fast charging.
Church, yes, sir.
Okay, so you remember these formulas only because we give you the parameter value. Okay, like why we are giving the K preterm, we are giving the R preterm. So can you calculate the percentage fast charging in
Yes,
that?
sir. Okay.
Okay.
Okay, sir.
Anything else?
Sir, what topic was discussed in last week?
Last
I
week we discussed the week
last
9
class
content.
at
In the last
Tuesday.
class we discussed that week 9. Okay, I just brief you about that one. In the week 9 we start with the different subsystem. Okay, week 8 will be start with the system. System is the Bluetooth headset.
Yes, sir.
Okay, in the Bluetooth headset there are the multiple subsystems. Okay, that we elaborate in the week 8. Now we are taking one subsystem, that is the charging subsystem. That is very important. Okay, why it is important? Because this charging subsystem will be the bone of every subsystem. If your battery is not charged, your system will not work. Okay, so charging subsystem will be do two things. One, when we connect my system in the power supply, okay, that power supply will be stored in battery. Okay, and when I unplug my power system, basically power supply, so the battery will be providing the current to all other subsystem. Okay, like for example, this is my system. I take this is my system. Okay, in the system it will be the battery. Okay, it will be plugged with the power supply. Now what is going to happen? When we connect with the power supply, the current will be go into the battery and no current will be going inside this one. So I is zero in this scenario and I is maximum in that scenario. Okay. And when I remove this power supply, the current will be provided by the battery, so I is maximum. That is required by the system.
Yes,
Okay.
sir.
So that's why this all thing will be managed by the charging module, charging subsystem. When we provide the supply, when we're not providing the current supply to other systems, other subsystem, that all will be decided by the charging system. Like for example, if you are having a Bluetooth headphone, okay, and when you plug your supply, when you plug your Bluetooth headset, it will be automatically stopped. That means you can't connect that particularly when you are connecting with the power supply. Okay, that means battery will be in charging mode, and in this charging mode, they doesn't provide supply to other subsystem.
Yes, sir.
Okay, so for now, for a subsystem, defining two things is very important. One is the what is the chip selection and what is the performance. Okay, now we are taking some example that why chip selection is important. These are some examples I will tell you a little bit or more. Okay, so the chip selection and performance. These are the two important things for a subsystem. Why chip selection is important? Any idea why chip selection is important?
Because how long the battery will it will operate or uh, uh, take the charge,
No.
the quality or
Chip selection, if I am taking chip selections, okay, I am not taking about the bad charging system here. I am taking if I design a system, so chip selection is a very important because it bounds the system. Like for an example, what is the meaning of it bound the system? I am using i3 chip. Okay, i3 means I think you are aware i3 processor. I am taking a normal example of laptop. I am using the i3 chip
yes,
and I want to connect a 32 GB RAM in that one. What will happen? System is very slow.
yes, yes,
Okay. Similarly, if I use a i7 chip with a 64 GB, I am using RAM. System is very fast.
yes, sir.
Why? Because i3 chip, the processing speed, the basically bit size, that is very different as compared to i7 chip. So if I similarly thing is if you have a iPhone of 4 GB RAM and you connect a memory card of 128 GB, okay, 128 GB memory card, it will hang. Okay. Second thing, if you are going to any shop, not a shop exactly, uh, any online store, okay, just select a phone of 6 GB. The maximum size of the memory will be 128. Okay.
or in some phone it will be 256 GB, but maximum it will be 128 GB. It will not having providing the 512 GB memory because
Yes,
it
sir.
will be hacked. Okay, if you go up to the 512, so either you purchase a 8 GB RAM or 12 GB RAM. They will support a 500, 256 and
12.
500.
Yes, sir.
So that's why the chip selection is important. Okay, because
Okay.
it bounds to some limitation. They provide some limitation. If you go use this chip, this is the maximum limitation. If you go with this chip, then this is the maximum. Okay, the chip selection is very important. Second is the performance. Now the performance will be decided by the some parameter. One is the form factor, one is the stability, or we call as the durability. Third, power consumption. Fourth, form factor. Okay, mainly for some form factor we already defined. Price. That is also very important. Okay, power consumption. What is the effect of power consumption? Like you have a 5000 mAh battery in your mobile phone, that will be lasting for 12 hours. Second, if you have a 4800 mAh battery, and that will be lasting for 36 hours. Which system you prefer? You have a two different mobile phone. One as a having a 5000 battery, second as a 4800 mAh battery. This will be going up to the 12 hours. This will be going up to the 36 hours. Which will better for you?
For 4,800.
4800 with a 36
Yes, sir.
hours.
It will be lasting long time.
Divyanshu, are you able to speak? Divyanshu,
Hello.
you are speaking.
No, no, no.
So that's why the power consumption, if you use any battery, so power consumption we require that should be less. Okay.
Sir, what about form factor? What
Yeah,
is?
form factor I tell you. Form factor will be decided on different parameters. The parameter is the size, compatibility. Form factor will be decided on different parameters.
He is want to telling something, Divyanshu, but
Yeah,
not.
actually that's why.
Yeah, his voice is not.
Divanshu, can you write on the chat box? Dipanshu? Yes, Divanshu. Are you going to say something?
No, sir, not now.
Okay. Okay, so form factor is basically dependent on multiple parameters. one is the shape, second one is the size, third one is the hardware compatibility. Okay, what is the meaning of shape? I think you have a multiple chips. You are aware with that one. Okay, you have some ICs. Okay, and in the analog lab as well as other labs, the IC will be
Yes.
like that. It is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so this is the 16 pin IC. Second is option is that we have this one. Okay, the IC is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so what is the difference between these two? If you see, one is the size. Okay. Second thing is that in 16 pin IC, you can connect components this side and this side. Okay, if you want to connect a component here, so you create one particularly wiring from here to here. Okay. In the 16 pin, this type of IC, you can connect component in all four directions. 1, 2, 3, 4. Which will we connect these four pins we can use here, which will connect these four pins we use here. Okay, these four pins we use here. So you have a connected your component at different positions. So this is the effect of shape and size. Okay, now this will reduce the size. If you are using a second type IC, that will reduce the size. Okay, second is the hardware compatibility. Hardware compatibility is that I'm taking one example is okay. We have a different mobile. Everyone have a different type of mobiles. Okay, and previously they have a different chargers. Some will be using the micro C, some will be using the C type, some will be using the that circular shape charger. Okay, circular type charger. There's a different type of chargers. So your device is compatible with how many particular products that will be defined the compatibility, hardware compatibility. So all these parameters will be combined and they will define the form factor of any chip, any particular system. Okay. Now what is the effect of this one? Like for example, you are designing a Bluetooth earbuds, okay, and you are using Arduino in that. I think you are aware with the Arduino.
Yes, sir.
Okay. You are designing a earbud and you are using the Arduino. So is it feasible? Definitely no. Why? Because the Arduino size is too large. Okay, if you design a earbud using Arduino, so your earbud size
Hmm.
is too big, you can't carry it anywhere.
Yes, sir.
Okay. Similarly, if you are having a different, I think you have a different pen drives with different companies. Everyone have a USB cables. Okay, USB port. It is not like that. Someone will be having a USB port. Someone will be having a different ports. Okay, so you can't operate other ICs because, like for example, I have a USB port, the standard USB port. Some other company have a USB port, but the size is different. It will be bigger. Okay, so it will not fix in all the systems. Okay, so you have to maintain a size. You have to maintain a particularly shape. So it will be compatible with all the available systems. Okay, so all these parameters will be defined in the form factor. Any doubt? Like for example, a simple case is that I think you have a LED bulbs with you. Everyone have a LED
Yes.
bulb. What
Yes, sir.
happen if LED bulb basically holder will be having a different size? Different companies are there. Okay, everyone design the LED bulbs. Okay, but the holder size is different. What is the issue in that? Yes, any of you?
The size, their size are different, and for used in different portion that will be. Uh,
I'm taking this diagram. I have a LED bulb. Okay, I'm not getting that. Okay, this is the holder size. That will be fixed in holder, wall mounted holder. Okay, one will be having a size of this one will be having a size of this one will be having a size of this one. Okay, this is the company A designed by company A, designed by company B, and designed by company C. Now what will be happening? You can't fix your LED bulb anywhere. Can't fix. Why? According to the holder size, you have to choose which LED bulb you can use.
yes, sir.
Okay, so this is the problem. So to make it universal, we design a system that is compatible with all other standard systems. Okay, so that is basically the compatibility. Now, similarly, we have a design a i7 processor. Okay, and I am going to insert a DDR3 RAM. You are aware about the DDR3, DDR4, DDR5 RAMs?
No, sir.
Okay. So these are the RAM, particularly DDR3, 4, 5 are the different type of RAMs. DDR3, DDR4, DDR5. These are the different RAM. Only the difference is the size and the speed. Okay, DDR5 will be work on a 72 meg MB per second. I think the unit I don't know into 10 raised to power 6. I just mentioned it. Power 6. This is the speed. This speed is the 3500 into 10 raised to power 6. This will be speed up to the 2400 into 10 raised to power 6. Okay. Now I interface this RAM with i7 processor. Okay. So DDR3 will not work. Why? Because i7 processor speed is higher than DDR. It will not compatible with that.
It will go for I3.
Yeah, if we have to go for
Yeah.
DDR3, I have to go i3 where the speed will be equal or less than with the DDR3 speed.
Sir.
Okay, so either we have to in i7, either I have to go with DDR4. Generally nowadays DDR5. Okay, so this is the hardware compatibilities.
Okay.
Okay. Anything else?
Sir,
Hmm.
did you solve the quiz to last question?
Okay, I'm not solving that. I can, but I can solve it.
Uh, if you can solve, then please solve and share the.
Okay, I will solve and share it with you.
Yes. Last question I can't finish in time, and uh, it will be confused me to do that.
Okay,
Third question.
okay, okay. I will solve and share it with you.
Okay, sir.
Anything else you want in week 9? So next week onwards, what we are going to do is, I think week 10 or week 11 part is not too much typical. Okay, so in the one live session, we will go with the week 9, week 10 part. Okay, and in the one live session, we are doing some practice because when I checked your copy, I have doubt that you are even though not properly write the equation applying KCL. You are confused in the KCL part also.
Yes, sir.
So that will because of that one in the quiz 2 you are that is a time taker.
Yes, sir.
That it
I
will be run
started
out.
from last question, but last question is very lengthy. That will take long calculation in two
Okay.
part. I little bit take time. Second question is okay, and but last question.
Even though in the second question also they are not getting the exactly V out, but that is the simple question we are doing in week 1, 2, 3, week 1 and 2. Okay, they are not even though calculating the properly V out.
Okay,
Okay, so one session we are taking as a doubt session for the current week, and one session we are taking as a practice from the previous weeks.
okay, sir. It will be better for us.
Yeah. Okay. Anything
Okay, sir.
else you want, you can ask me. If you have doubts, you can ask me. Suma, are you trying to solve that question at home?
Third question.
Yeah.
Till now, I will try then again to
Hmm.
solve.
Actually, in the exam, there is a different mindset, no? So
Yes, sir.
I will solve and share it with you, but just try and solve it by your own also. Okay,
Okay, sir. Okay, okay, okay. I will try. It will take
because that
time.
will be yeah because it will be tell you that you are doing mistakes because of the examination load.
Okay.
Okay, and that will be after that you realize that it question is very easy. Okay, so just try it by hand. I
All
will share.
questions are easy, sir. It will little time consuming for calculation,
Okay.
but questions were all three questions are easy to solve because I understood the question, but
Mhm.
they are
I think we already solved this type of questions
yes, sir.
in our live session also.
Yes, sir. Yes, sir.
Okay, fine. You just try to solve it again,
Yes, sir. Yes, sir. I will try to solve it again.
and till that I will share the solution with you.
Okay. Okay, sir. Okay, sir.
Anything else, Divyanshu? You want to ask anything? Any doubts?
No, sir.
Okay. So I think we stop here.
Okay, sir. I will go through week 10. Then,
Mm.
if
Yeah,
any
yeah,
doubt,
yeah.
I will.
Week Tuesday we will take the doubt session, and week Friday we will solve some
Okay.
previous term question. Okay.
Yes, sir. Yes, sir. Okay. Okay. Okay, sir.
Thank you all.
Yes, sir. Thank you, sir.
Thank you, sir.